Okay, hitting recording. All right, and I have also on the line with me Augusto Goncalves and Adam Nagy. Can you guys hear me okay?
Yeah.
All right, awesome. Thank you. Okay, so let's get started. Well, good morning and good afternoon to all of you. Welcome to the workshop on how to get started with Autodesk Forge. Today, I will be sharing with you some material in order to use our technology. So my name is Jaime Rosales. I'm a senior developer advocate for the Autodesk Forge platform. Feel free to follow, tweet me along at AfroJME. As you can see, the hair is real, so it's part of the handle. And today I'm doing this workshop on behalf also of the Autodesk Forge team and the AEC Hackathon community. So let's move along. Something that I want to point out before we continue, it's that one of the reasons that we are hosting this workshop, it's because in the upcoming event, the AEC Hackathon going virtual, starting July 10th to the 26th, we will have two challenges on behalf of the Autodesk Forge team. One of the challenges will be the best BIM 360 project, and another one will be the best design automation project. So we will have prizes available for you guys. So in this case, attendees will need to register in order to participate in the hackathon. If you register, then you need to attend the official start of the hackathon, which will be July 10th at 14 o'clock Eastern time. So that's 2 o'clock New York, east side coast of the US, for the lighting rounds and the team building. And like I mentioned before, for these challenges and many others that are posted on the AEC Hackathon site, we will have prizes available for you guys. Also, how do you ask questions during this workshop webinar? So, like I mentioned before, I have two of my colleagues at the moment in the webinar. They are Adam Nagy and Augusto Goncalves. Can you guys say a quick hello?
Yeah, hi everyone.
Hi everyone, good morning. This is Augusto.
Your microphone needs to be thumbed up a bit, Augusto.
Yeah, you're a little bit far away.
That's
there we go.
Okay.
Perfect.
Sorry.
All right, awesome. All right, so.
And by the way, it looks like someone might have a question. Patricio raised the hand. I don't know if.
Yes, so we can, I'll say, because we have like an hour and a half in total to get this workshop started. The raise of hand, I think we might want to maybe transition it to a Q&A or a chat. And that way, while I'm presenting, my colleagues can help me out with answering your questions, okay? During the workshop, we will have an opportunity for you guys to also speak up in case there is something very specific that you want to ask and you might need help, let's say sharing your screen or something like that. But like I said, we're a little bit tight on the time and I want to get you started with the technology. So in that way you have a new tool to use and consider for participating in the hackathon, okay? So, but in order to get started with this, I'm aware that some of you are not familiar with what Forge is. So let me give you a little bit of background of what Forge is, and then we can kind of like move along in regards to that. So Forge is Autodesk Cloud Development Platform. Forge, it's the platform that is a set of web service APIs to help you build the next generation of cloud power applications. So the Forge APIs help you tap into your design and engineering data in order to streamline and innovate how you work. So Forge empowers software developers like you guys to build applications that can automate processes, connect teams and workflows, or simply visualize or analyze your CAD data, okay? So this is one of the reasons we have the Forge logo in the cloud as one of the API services. that allows you to, your client side, to connect to these APIs in order to do visualization of that CAD data directly on the web, analysis of an external database with data that it's coming in from, let's say, a CAD model, and be able to visualize this. So I don't want to spend too much time into what Forge is in general. This is just kind of like a quick summary. And I think I want to give you a little bit more in regards to the visual content of what's the capability of the platform. And then we will get moving and started with the workshop, okay? So let me move along. Okay, so let me click you stop my share my screen again. Okay. So if you have more questions about the AEC Hackathon online, you can find out at hackaec.com, where you can learn more about the schedule, a little video about that has been done in regards to what the AEC Hackathon is, in case you're not familiar with. A little bit about the schedule as well. So in this week, we're hosting the workshops. So there are many other workshops that you guys are free to sign up as well. And then, like I mentioned before, the lighting rounds, presentations, hacking deadlines, winner announcements, and team presentation judging. So feel free to visit the site, and that way you guys can get started and register. All right, so moving along, we have an application hosted on the cloud. So before, let's say you wanted to visualize a Revit model, an AutoCAD model, a Navisworks model, even like a T-out model, you will always have to find the software that would allow you to actually let you visualize this kind of data itself, like the CAD data. With Forge, no need to install any plugin. This is running on a web browser. Any browser that supports WebGL will work for one of the services, which in this case is the viewer, okay? The viewer allows you to visualize all your CAD data directly on the web, and not only the geometry and the pretty picture of this, it also lets you visualize everything in regards to the metadata of that model. So let's say we want to visualize everything that matches the category of a wall. We can highlight those kind of walls. Let's say everything that matches the category of a door, we can highlight those doors and even isolate in order to only visualize the doors that are part of this model, okay? So, but at the same time also, we are aware that there is certain data that maybe is not originally part from the model. So let's say we have some sort of a bill of materials database that we want to include into our model. And in this case, on the right side, we have an external database that it's coming from a cloud service. In this case, it's MongoDB. So everything that it's related to, let's say, brick as the material, or concrete, copper, glass, we have information about who the supplier is, the price per kilogram, in a different currency that we can price up those materials. So let's say we want to see everything that is concrete based. So now we highlight everything that is concrete based in the model, right? We have a specific price, which is 100 euros per kilogram. I'm a software engineer. I don't do bill of materials, so you guys can judge if it's expensive or not. So now we highlight one of those pieces and we visualize the properties about that selected wall, which is of material concrete. And then if we move along to the properties, let me just hide my table from, okay, if we move along to the properties, we see that we also have a way to interact with the database that we are reading from an external source in our model itself. Just keep in mind that this part of it, it's kind of like a view only. So whatever happens in the viewer, if you want to keep a record of those properties itself, you will need to store it on your own site in an external database. Now, if you want to inject that database now into the original Revit model, there is a capability now using one of the other services from Autodesk Forge, which is called Design Automation. And I will talk a little bit more about Design Automation when I reach out to one of these links in order to show you something that you can do using design automation in this case. Okay, so let's move along. So let me show all the objects again. Now, we have certain capabilities in the model as well. We can break the model apart into different pieces. We have a measuring tool. Let's say we want to measure from one point to another. So we have a way to calibrate this measuring tool depending on what kind of unit type do you use, and also the precision that you want to use on this. So let's say we want to extend a little bit. We see now our precision actually increases. So the measuring is a little bit more, I guess, accurate in this case. And so many other things we can use in regards to the different tools available within the technology in order for you to interact with your CAD data. Okay, so let me move now to another one. So in this case, we have a visualization of a Revit model. And we know that Revit models are composed by either 3D views or 2D view sheets. So the viewer itself has capability as well of visualizing those 2D view sheets. And those 2D view sheets can be listed in a separate component in order to create a viewer dedicated only for the 2D viewing components. So let's say we want to see everything in relation to the first and second floor of that building. So now if we highlight something in this, you see that now I'm actually getting a highlight on the 3D view. And the reason why is because those IDs are basically the same ones. At the end, these are not two different models. This whole thing is part of a Revit project and allows me to do an interaction with the IDs that are either on the 2D view or on the 3D view in order to get some kind of highlighting into the model. And at the same time also, we're composing some graphical content in order to visualize, let's say, system type properties that are pertaining to this model into a third-party library. In this case, we're using d3.js. So we can highlight everything that is part of the supply air or everything that is from the sanitary piping. So we have a way to visualize these kind of components by filtering the data and composing this into a report kind of way. But also, we have a way to interact with those individual pieces of the data itself, right? So let's say one of those KUKA robots, we can create a set of sequences of movements that are actually previously stored as viewing states. And I'm showing this KUKA model because it's an attractive model in order to get you realize what are the kinematics of one specific model. But let's say you want to create some sort of experience of a navigation path inside of your building. With the use of these viewing states, you have that kind of capability in order to store it in a different database and then just create that sort of animations. So if you ever have done like some sort of cartoon drawing as a kid, I used to do it like in Post-its, you do one by one, and then once you flip them, you start seeing like some kind of animation. The same way and the same principle kind of applies to this. You're managing every single viewing state, and then from there, you're able to create this sort of sequence in order to do this kind of visual component part, okay? Now, we're familiar that there is a trend in the industry right now, which is called the digital twin. So basically, we have a way to interact with our data itself from the manufacturing side and also the construction side. So in this sample, we have, let's say, a turbine that is having some data that is coming in regards to the performance of the turbine. We have a way to visualize certain data, like heat map of the turbine, so which parts are actually getting a little bit more hot than other ones, so like an issue frequency, or maybe when is the time to the next scheduling part. So we know that this part, it's actually gonna have to be maintained sooner than the green one looking, okay? At the same time also, we have a way to add markups into the turbine. So if we add certain issues to highlight, I know this might be quite a lot of stuff, but it's just kind of trying to prove a point of the capability of the technology itself in order to tag along specific individual pieces in the model in order to represent an issue with a market. So let's say if we break out this model into pieces, we see that also those pieces are starting to like move along into following which parts are actually the ones tagged to it. Okay, so let me get rid of the issues. Let's get rid of exploding. And at the same time, like I said before, the viewing states can allow you to do some sort of animations, but also if the model comes in with certain animations, there's a way to enable that directly from the viewer. Okay, now coming into, let me get started with this. So coming into the use of design automation. So design automation, basically, it's one of the services that we have available in the platform in order for you to be able to automate tasks in certain engines of our technologies. Those are Revit, AutoCAD, Inventor, 3ds Max, and just recently added as a beta version, Civil 3D. So what that means is that if you have experience developing, let's say, plugins for this kind of engines with their native API, so let's say Revit API, and you want to automate a task directly from a web application without the need of opening that desktop application in order to run one of your plugins. So let's think about like a Revit add-in, right? So the Revit add-in, what it does is that it begins with a certain project that will be a template of 3 walls and a floor, because you want to do this kind of like Revit room configurator in order to get started from somewhere and not have to be tracing every single wall at the beginning of your starting point. You can just simply run a plugin and create this. So that same principle is actually being applied here. So we have a simple canvas where we plot a couple of lines. We do it a little bit smaller and that way it's a little bit quicker. We plot a couple of lines. These lines will represent walls. Now, we're gonna select a floor in order to connect those walls to a floor. Okay, now we plotted 3 walls and a floor that connects all the 3 walls. Now, as you see, I'm running on a Mac, so I'm not even have Revit at this moment in this computer. So if I do, and I hit generating a Revit model, design automation grabs the entry points that I plotted on my canvas. It starts creating a Revit model. So it sends it up to the server in order to run the add-in that it's being prepared for Revit to run on the server, on the cloud server, creates this Revit model, and then brings it back to me. Now we have this workflow running in Forge by going to a translation of that model into model derivative to give us back a model that we can use directly in the viewer by giving us first a preview of how that model looks, the one that I just built. So now if we click that, let me just move along some stuff from here. If we click that, now we have a working model of the ones that we just plotted in and created. And these are not only 3D meshes, they're actually parts of a Revit model. So we can highlight those walls, and we will see that we get all the properties that are something recognized in the Revit world, I guess, as a basic wall with all the different kind of information that our Revit wall should contain. From there, we also have a chance to download this Revit file. So we have now the Revit file available for us to bring it over to Revit and continue doing work with that, if that's something that we're looking to do. So now, at the same time also, we have a way to do some sort of configuration. On the right side, we have a gallery of different Revit families. So let's say if we select a point, we want to bring in a bed. We brought in a bed. We select a point, we want to bring in, I don't know, a refrigerator. It kind of looks like a New York City apartment because everything is on the same place. And then later on, we bring in the stove. Okay, so now we have a way using some floating thing keeps getting in my way. If we select one of these ones, we can start repositioning things in the Revit room the same way for the fridge. Maybe I want to keep a drink nearby my bed, and then we can reposition objects into the room itself. Okay, so there is ways to interact with this kind of technology in order to manage most of the Revit functionality if it's available through the API in order to handle it over from a cloud application way. Okay, so let me get back to my slides in order to get started. Okay. So now, what we're going to be working during this a little bit over an hour time that we have left, it's a simple application that would allow us to interact with some of those Forge services, being the authentication in order to authenticate ourselves to the Autodesk server, the creation of a bucket, which in this case, it's a container that we will use to do the storage of our files in the cloud. Later on, the capability of translating those files into a format that the viewer needs in order to understand the geometry and the CAD data that will come along with it, and be able to interact with the viewer. Okay? So, as some of the requirements in order to get started, I will need you to go ahead and create like a Forge account. So you will head over to forge.autodesk.com. Later on, we will create a Forge application. For this workshop, I'm going to be working with Node.js, but there is capabilities of using other server-side languages like .NET Framework, .NET Core, PHP, and those tutorials are available if you guys want to look into it later on. And then also, I will be using Visual Studio Code as my Visual Code, sorry, as my IDE for this part. Okay, so I will walk you through these steps really quickly in just a second. So, and the instructions can be found at this URL. So I will ask you to head over to learnforge.autodesk.io in order to get started. So let me head over to that site, and that way we can get started. And Adam or Augusto, do we have any questions so far?
I have not seen anything.
All right, awesome. Okay, so let me kill some of those. Okay. Let me hide my floating Zoom thing as well. All right, so now we're gonna head over to, like I said, learnforge.autodesk.io. In here, we have instructions for you in order to build up your first Forge application. Like I said before, what Forge is, it's something that allows you to do interaction with the visualization of 3D models, manage your data, and also convert your design files into a format in order to unlock their potential in the cloud. Okay, so there is a section here that says before you start coding. So before you start coding, we're gonna head over to creating your Forge account. So you're gonna head over to the Forge developer portal, hit the sign up button, or sign in if you already have an Autodesk ID account. Later on, if you haven't done this in the past, you're gonna activate a subscription. So you will start a free trial. this free trial will be valid for 90 days. So you get some free cloud credits and some storage in order for you to be able to interact with it. When you create an app, you're going to be using this as a callback URL for now. This callback URL, we usually need it for a three-legged authentication whenever we do BIM 360 integrations or something like that, which is a separate workshop that I will be actually hosting tomorrow. So if you need more information about that, I can give it to you at the end of this. And we will be selecting some of those services in order to get started with our application. This will give us back, once it's created, a set of API keys, which will be the client ID and client secret that we need in order to get started with the use and the permissions of the Forge platform. Okay, so let's really quickly head over to forge.autodesk.com. Where I have an account, so I'm gonna do sign in. I'm not gonna be using my Autodesk one. I wanna use something like you guys will be using. And then we're gonna sign in. And this is gonna send a two-factor authentication to my phone. So 25, 35. Okay, so now we are in the My Apps, and then we can go ahead and create a new app. So we're gonna create a new app. But first, let me grab this callback URL. We have some services already selected because this account has started the free trial. So if you don't see all of these ones, I will say you need to head over here, go to Forge account details, and get your free trial started. Okay? So we're gonna name this AC Hackathon Workshop. Workshop. Callback URL. We're gonna leave the website URL empty right now since it's an optional parameter. We wanna create the app. So now we have a client ID and a client secret that we will be using in order to get started with our application. So let me get back to this in a second. So we get back to the start of coding. And I will be doing some pauses just to check on you guys, how are you doing? But I just want to get through this first part in order to get all set up, and that way we can move along. So now, like I said, for the tools, I'm going to be using Node.js, and I'm going to be using Visual Studio Code. So I do have Visual Studio Code already, but this is where you will get it. So depending on what kind of OS system you're using, you can select download for Mac or download for Windows, depending on what you have. And at the same time also, you will need to install Node.js. So Node.js, what I would recommend is the LTS one, which is the most recommended one for users, okay? I would say do not get this one yet. This one has a lot of latest features. Unless you're very advanced in the use of Node.js, I would not recommend getting this one. So get the one for the most users for now. And then later on, we will move into the part of authentication. So I will do a quick explanation about the authentication and the scopes. But actually, I can do this when we get started with the tutorial. Okay, so I created my application. I have Node.js already, and also I have Visual Studio Code. So let me do a quick check. And let's see how you guys are doing. Can we send a callback URL? Yes, here you go. And Cyril, give me 1 second. I'll ask you right now. Okay, cool. So let's see. All right, so far so good. No questions at the moment. If you have questions, just ping us on the chat, and then my colleagues will be helping you out with those questions. Okay, so we can move ahead. So now, this is the tutorial that we're gonna be working on in order to get started with the visualization of your models, right? So to view your model, you will need the following step. So if you're a first-time developer, you should start here. So we're gonna get started here. So we're gonna head over to create a server. And like I mentioned before, if you have experience in any of the other languages, feel free to move along with one of the ones that you feel more comfortable with. Remember that the Forge platform, it's most of its services are REST API based. So any kind of server-side language will work. The only one that it's dedicated to JavaScript will be the viewer, right? Because the viewer, it's based on WebGL and 3JS, and we need JavaScript in order to interact with the viewer. But for this workshop, I'm gonna move along using Node.js. So as first steps, it says create a new project. So a new Node.js project. We're gonna call it Forge Sample. And then we're gonna open Visual Studio Code, go to File, open a folder, and select a newly created folder. Then in Visual Studio Code, we will add our integrated terminal, and we will start our Node.js project with npm init. The only thing that we need to keep in mind is that when the entry point gets asked, actually instead of index.js, which is the default, we'll be using start.js. This will create a package.json file where we will be later on installing our node modules that we need in order to work with this workshop, okay? So let me get started with that part. We will go into Visual Studio Code. All right, so I have a folder which is called the AAC Hackathon folder. So let me open this folder. Okay, now we're gonna do a new terminal. So this terminal, it's located in this AAC Hackathon folder. So we're gonna make a new directory. It's gonna call Forge Sample. So as you see now, we have a Forge Sample 1. So now we're gonna cd into this Forge Sample. Okay, there's nothing in here yet. To make a quick check if you guys installed Node the right way, you can do a quick Node version on this terminal, and this will give you a version if Node was correctly installed. Because we will be using npm, and when you install Node, also npm comes along. So you can also do a check of the npm version. In this case, we have the npm version installed, all right? So now we are inside of here, and we said that the first part that we need to do is to do the npm init in order to get our Node.js project started. So this will start asking you a series of questions in order to compose your package.json file. So it will be Forge Sample being the package name. We're gonna say yes, so just hit enter. The version 1.0.0, yes. Description, workshop, AAC Hackathon. Okay, entry point index.js. So in this case, we said that our entry point was going to be start.js. So start.js. Test command, we're gonna leave it empty for now. Git repository, we do not have a repository yet. This is something that you guys can fill out later whenever you upload it to Git. Keywords, Forge, author, your name, in this case, Jaime Rosales. License, let's switch it to MIT. Now, it gives us a preview how our package.json will look. And I think everything looks good. So we're gonna hit, is this okay? Yes, so yes, enter. So now, if we expand this, we now have a package.json file that got composed with the information that we just created. Okay, so now if we get back here, we're up to this point. We're gonna start installing those packages. So now we will be using npm install in order to get Express Server, Molter package that we will use for file upload, and of course the Autodesk Forge npm, which in this case is the Forge-APIs. So you can copy from here and paste it in the terminal. I know this one's, so 1 second. Okay, so now we're gonna do npm install Express, save. So now it's starting installing Express into my application. So now we have a dependency, which this will be Express. And we also see that a no modules folder just popped out, which includes all the different modules that Express needs in order to work. So we're going to do npm install Molter. And same thing for npm install Forge APIs. Okay, so now in the dependencies, we see that we have the 3 that we need in order to interact with our application. Okay, so we did it all from the terminal directly inside of Visual Studio Code. One of the reasons I like Visual Studio Code is because there's a lot of different things that you can run directly from the IDE, and that actually makes it attractive to me. All right, so now, as a result, like I said, we should have a package JSON that looks in some way similar to this. I did change the license, and I did not add some of the scripts, but feel free to add them if you want in order to do an npm start. But I will show you a different way to debug your project. So in that way, you take advantage of debugging on the server side in case something goes wrong. So now, for the files and folders, we need a certain structure inside of our Forge sample application. We will be creating a routes folder for all the server-side files and a public folder for all the client-side files. So at this point, your project should have the following structure. So right now, it does not. I think it's missing the node modules here in the picture, but yeah, it should be in there. So we're gonna get started with a folder. Oop. This is not gonna work. So we're gonna select folder and add a folder in here. Public. Same time again. Select this folder and routes. Okay. So now we have public routes package.json and package log.json. This got created by the npm install, so don't worry about this file itself. So now we have a way to take advantage of Visual Studio Code and use a launch JSON configuration. So this launch JSON will let you select the environment that you're going to be running on, in our case, Node.js. And from there, include the values for our Forge client ID, client secret, in order for them to not be exposed whenever you're running this. So you can copy to clipboard this, and let me do something really quick. That way I don't mess up my file structure. I actually want to get started with this one. Yes, so kill this one. What I just did is that in order to have Forge sample as my main folder, and that way if I add new folders and everything, they all come in here and I don't have to be worrying about selecting somewhere else. Okay, so now if we go to run, we have a way to add a configuration, and then we can select Node.js. And now Visual Studio Code added a new folder, which is called .vscode, with a launch JSON file inside of it that allows us to do the setup in order to have the debugging configuration handle for us. So we can copy all this, kill it, and paste what we actually just copied from the tutorial. So now, if you remember, we created the Forge application where was going to give us our client ID and client secret in order to input those in here. So since I'm doing this as a tutorial, I don't mind if you guys see my client secret, because after this, I'm going to kill that app. So I'm going to create, if you do a simple click, it copies it. And now paste it, save it. And now we have our launch JSON set up. So we don't need this one for now anymore. Okay, so let me head and set up our terminal too. So getting back to here, we set up our launch JSON configuration. So like it says before, it's important that you define the client ID and the secret as the environmental variables, because our project will be using a reference to those, okay? In case you have not set it up, you will get some sort of console error with the next file that we will be creating that you're missing either of them, okay? So now we're gonna start building our start.js file. So in the root folder, we're gonna create a start.js file that will contain the following code, which basically will start setting up the Express server in order to do connections to the authentication, object storage service, and model derivative route that we will be creating later on in this project. So we can do a simple copy to clipboard, get back here. In this location, we're gonna create a new file, which is gonna call start.js. Paste this here. So now we have everything that our start.js file will need. So we're gonna quickly save this. And then we're gonna do the same thing again for a configuration file that will help us handle those environmental variables that are gonna be coming in from our launch JSON configuration. So when the process runs, the process environment variables will get a value, and they will start getting assigned to these variables for later on being used in the application for authentication. We will also define here a set of scopes that are required for our server-side application and a scope that is required for the public. So now I can go back and explain what a scope is. So let me just quickly move here, and we will get back to this in a second. In the meantime, I can ask if there are questions or anything that I can help out with. Okay, nothing here. Okay, cool. You guys are handling. Thank you guys for the help. All right, so the authentication that in this workshop we'll be using, it's a two-legged authentication, which is different from the three-legged. So a two-legged, basically, a simple explanation will be me as the developer are asking the Autodesk Forge server for permissions to interact with the services. So I pass in my set of API keys to tell the server, here are my keys. Can I get access? Since I send out the correct keys, the server will give me access, okay? So this is what we will be using. And then scopes are basically the permission that those keys are coming in with. So there are certain scopes that are used for public or internal tokens. One that it's recommended for public, so in this case, our client-side application, right? So our client-side, whatever we're gonna be interacting with, or our clients are gonna be interacting with, they only need a certain scope in order to visualize the model, for that matter. But there are some internal tokens that request a specific permission in order to create buckets, read data, create data, or write data into it, okay? So there is a way to handle this in a more secure way for taking into consideration the public and internal token part of it, okay? So now, get back to here, as I said, we are gonna define also, whenever we're using API calls that require an internal scope, we already assign the permissions. But if later on we use one that it's gonna require a public access scope, we already define the permissions. So we're gonna copy to clipboard this, we're gonna come in here, I'm gonna add a new file. It's gonna call config.js. Paste this here, and now our process environment is gonna be read from the launch.json configuration at the time that we run the file. So we're gonna save this file, and now we have this part, okay? So we define our environmental variables here. So this time of running our Express server and the values of these variables will be used to connect to the different Autodesk Forge services we will need, okay? So the project is ready and kind of like at this point, but it doesn't do anything yet because we haven't set up the authentication, the part for managing the storage, and also the part for using model derivative API in order to do the translation of those files. So we can start moving along with that. So your project at this moment should look something like this, where you have the VS Code launch.json, config.js, package.json, start.js, package-log.json, public and routes folder. We have a node modules missing in this picture, but you should have the node modules as well. So next, we're gonna start with the auth two-legged authentication. So again, we're gonna be choosing Node.js. And then for a basic authentication implementation, we will need two files. The first one will go into the routes folder, and we're gonna call it auth.js. So we're gonna create the auth.js file that will take care of creating an express router for the auth-related endpoints. So whenever the router gets a call to /token, it will run this function inside of it, which we'll be talking also to the get public token inside of a different auth file within a common folder. So we will be building that one next, okay? So quickly, we're gonna do copy to clipboard. Inside of routes folder, we select routes folder. We're gonna do new file, auth.js, paste this, save. Okay, so again, the router /token will be getting our access token based with the reference to the get public token. But we don't have this reference yet. And this is something that we need to build right now. So we're gonna hit routes. We're gonna add a folder. We're gonna call it common. Inside of common, we're gonna add a file, which is gonna call again auth.js. We're gonna go and get this code here. So again, we create a common subfolder inside of routes. So now our path should look like routes, common, auth.js. And that file will actually do the requests for the access token for Forge that will be reused in other parts of this tutorial. So we have, using the configuration.js file that we created before, we will get the client scopes, we will get the token, we will get a public token, and we will get an internal token. We will export those functions. So copy to clipboard, go back here, then we save this, okay? So now we have, sorry, my zoom bar is here again. So we have now the Forge APIs requirement, the config requirement, the get client, which is reading, using one of the functions in the Forge APIs module, which is going to be the auth client two-legged, passing in client ID, client secret, the scopes, or the internal scopes in that case. Later on, we will get the token, right? So get the credentials, authenticate, We'll set a timeout in order to do some credentials expiration. I think the credentials expire after an hour, so the token is valid for the use of an hour. We will do the public token, so get the token using the public scopes, or get an internal token using the internal scopes. Okay. Now, make sure that we have this file saved. Now we're gonna move along. So to avoid getting a new access token for each end user request, we will add the unnecessary latency. So let's cache them in a global variable for after an expire in seconds. So this is what we did up here. So in that way, we are not getting tokens every single time because the token itself has an expiration time of over somewhere closer to an hour. So now we need to upload that file to our object storage service. So now we will be using data management API in order to do that upload to the object storage service. The buckets in this case, if you're familiar with AWS S3, kind of like it's basically the same kind of principle. A bucket being a container that will help you store your data. So in this case, your translated data or your CAD data itself. It depends what you decide. Has three different kind of retention policies. So transient, which basically will cache like storage for only 24 hours. So this is ideal for like ephemeral objects, so something that you don't want to keep a record of. So after 24 hours, it will expire. In this tutorial, actually, we are using a transient policy. So also we have an option to do a temporary, so that it will persist for 30 days. And then a persistent storage that will persist until you delete it. So we will go ahead and create this endpoint in order to create buckets, upload files, list the buckets, and the objects. So again, we select something to keep in mind with the buckets is not to use any kind of special characters. So the lowercase letter characters are required, so no uppercase or anything like that. So we get into Node.js. So now in this section, we will need to create these three features: the creation of bucket, listing buckets and objects, and uploading objects. So again, in our routes folder, we will go ahead and create a new JavaScript file, which will be the oss.js file. This will include the use of Multer, which we need in order to do the file upload part. Okay, so we can copy the clipboard, head over here, select routes, add a new file, oss.js, paste this, and then quickly going over, we will need an internal token in order to interact with these endpoints that we are just creating. So we have an endpoint for buckets. So this will allow us to get information about the buckets using the buckets API inside of the Forge APIs module. Later on, at the same time also, if the bucket is part of it, so we can start navigating down in order to get the objects in that bucket. We have another one in order to create the bucket. So this will be a post API endpoint for buckets in order to create that. This is where we put up the policy. So in case you wanna later on change it, this is where you can change the policy to any of the three that I previously mentioned, which they were transient. Let me actually get back here. Transient, temporary, or persistent. We're using transient at this time, okay? This will create a bucket, passing in the authentication client, the token, and also the payload. And then later on also, we will do an endpoint for the bucket, for the objects. So this would allow you to upload a new object into the given bucket. All right, so now we save this. So now your structure should start looking like this. Right? So we have auth, OSS, a common folder, which also has the auth.js. These two are not the same, are different, but they complement each other. Okay, So now, let me get back here. So also in this tutorial, we're using a third-party library. It's called JS3. So this JS3 will let us see our buckets and objects in a tree-structured way. So that's one of the reasons we're using this library. And like we mentioned before, in order to upload, the endpoint uses motor module to handle the file upload. If you prefer any other kind of module to handle file uploads, feel free to use it. All right, so now we gotta move along in order to translate the file. So this is when we get started with Model Derivative API. So let me just do a quick check. I see Q&As are empty, chats are empty. All right. Let me hide my floating meeting controls again. And let's get back to this. So now, when using Model Derivative API, we have different kinds of results, okay? Basically, you get a source file, in this case, your Revit file, your AutoCAD file, Navisworks file, SolidWorks, CATIA, Rhino, whatever you want to use, SketchUp, doesn't matter. Gets a source file, and Model Derivative has different sets of outputs. In this case, the most common used one is source file, let's say Revit file, gets into Model Derivative API, and we do a file translation into, let's say, an SBF or an OBJ or an STL. The SBF, it's what we use to visualize it directly in the Forge viewer. At the same time also, we have a way to extract a thumbnail. So if you remember, when I was showing the design automation for Revit sample, and I created my model of 3 walls and 1 floor, it gave me a preview of how that model was gonna look. This was using this thumbnail functionality. But then also, let's say you are a supplier of doors and you don't care about anything else than doors in that model, and you only want to visualize the doors of a building model. So you can do a geometry extraction that matches that kind of category and only get back the doors of that model. But let's say also you don't care about the geometry. You only want the data. You only want to find out about the measurements, I don't know, more information about one specific part of let's say, these doors or walls or whatever. You can get that data extracted as well, and it will give it back to you in a JSON format. So there are different kinds of outputs that this Model Derivative API can help you out with. So there is also a link to supported translations for the Model Derivative API. We have over 60 plus different file formats, not only from Autodesk technology, also from any other kind of CAD. Okay, so now we will need to do a call to the post job endpoint in order to start that translation process of the uploaded object into our bucket. So again, we're gonna get back to choose our Node.js language, and we're gonna do the translation model piece. So we're gonna create a model derivative.js file with the following content. So copy to clipboard, get back to routes. We're gonna do model derivative.js. I think I spelled that right. Yep. All right, paste this, and again. This will be using, again, the Express module, also the Forge APIs module. We will do a get client and get an internal token from our common auth file. Start our router, get the internal token in client as well. And now do the post to the /jobs endpoint on the model derivative service in order to submit our translation job for the object URN, okay? The URN will be what the viewer will use in order to identify the path of the file to the location of the bucket. This URN gets encoded in base64. So I will show you how that looks in a little while. Okay, so now basically we are done with our server-side part. So if we move down, we created a translation job that will help us extract the 2D and 3D views of our model. So to summarize, our Node.js project should look something like this. Routes, common. Inside of common, we will have auth.js. And later on, model derivative.js, auth.js, oss.js inside of the routes folder. Now, config.js in the outside part of it, and at the same time also the start.js with our package JSON. And at the top, the .vscode file folder with our launch.json configuration. Okay, so we are done with the server-side part. Now we're gonna head over to showing this in the viewer. So let me just do a quick check. All right, chat, Q&A, answer. Awesome. Okay, so let's move along. Let me hide my floating meeting controls again. All right, so now for the viewer, which will be the client-side library that Forge gives you, it's basically based on pure HTML5 and JavaScript, like I have mentioned before. So, but there are a few tips for the server-side implementation. So we're gonna choose a language again. So Node.js in this case. So our Node.js server is configured to serve the files from the public folder. So we need to organize its content like this. So if you see, now we're gonna go ahead and create our structure inside of the public folder. And this is something that we need to be careful with, because if our index.html ends up inside of the JS folder, there's no way that whatever we reference in the index.html file will find those files later on, okay? So now let's go ahead and create that file structure. We're gonna close the routes. We're gonna open public. There's nothing in public, so we can select this and add a folder. We're gonna start with CSS. Okay. So now in public, we're gonna add a new folder. We're gonna call it JS. And now in public, we're gonna add a new file and we're gonna call it index.html. Okay. So now inside of here also we will need main.css, forge3.js, and forgeviewer.js. So we can go ahead and create those two. So select the CSS folder, new file, main.css. We're gonna come back and fill out those in a second. So now JS, and it's gonna be forge3.js. I think that's what it is, yeah. And then forgeviewer.js. Inside of JS again, new file, forgeviewer.js. Okay, so now we have inside of our public folder a CSS folder that contains a main.css, a JS folder that inside contains forge3.js and forgeviewer.js. And at the same level of our folders, the index.html. Okay, so we're gonna go ahead and fill out those. So now we move along to the client side. All right, so the index.html will have certain libraries that we're gonna be using. jQuery for the DOM manipulation, Bootstrap for the styling, and JS3 for the listing of the bucket and objects, okay? We wanted to keep this as simple as possible, so in that way you guys can build on top of it and then just interact with however best fit your uses. Okay, so this is basically how the HTML looks. So we're gonna copy to clipboard this, get back to the index.html, make sure that we have reference to the Forge viewer files. So we need viewer 7. I'm gonna put an asterisk in order to use the latest version. If you want to specify a version of the viewer itself, you can do so here. This is for the style of the CSS of the viewer, so the toolbar styling and all that. And at the same time also for the JavaScript reference for the viewer API as well, referencing 7 dot and then asterisk in order to grab the latest one. Also the project files, which will need reference to, again, the CSS folder, main CSS, the JS folder for forge3.js, and the JS folder for forgeviewer.js. Okay, and we're gonna call it view models Autodesk Forge. All right, so everything looks around okay to me. So now I'm gonna get back to here. Now we're gonna move to do some simple CSS in order to style our application in a way for us to not have to worry about the styling of it right now. So open up the CSS folder, go into main CSS, paste this, and we have Forge Viewer, app buckets, body, fill, HTML body. Perfect. Save that. Let's move along. Now we're gonna do an interaction with the forge3.js. This is where we're gonna be using the JS3 library in order to compose our tree, in order to list out our buckets, gives us the chance also to have a button to allow us to create a bucket and then show us the different kind of objects that we're gonna be uploading to our bucket, okay? So we're gonna copy this, move to here, open the JS folder, open the forge3.js. This translation of object, it's basically calling out the jobs endpoint that we created in the routes, the model derivative one, uploading of a file. Also, whenever we select something on that specific JS3, we will be passing in the URN for that file and then do a launch viewer, which basically will reference to a new function that we'll be creating inside of Forge Viewer right now, where we pass in which is the path in the bucket to load what specific file, okay? So let me save this. Forge 3, done with this. And now we're gonna move along to the Forge Viewer. So Forge Viewer, if you see now we have that function that I just mentioned, which will be a launch viewer where we pass in a URN, we get a Forge token, pass in the URN for our document ID. If the document load is successful, we will get the viewables of that model and then load our viewer with that document and the viewables that are part of it, okay? So we copy that to clipboard, we go into Forge Viewer, paste that, and then make sure that I did the right one. Yes, launch viewer, initializer, on document load success, failure, get a Forge token. All right, cool. So now we move down, and then to summarize the UI, like I said, we have 4 files, index.html. Oh, my computer froze. There we go. Can you still hear me?
Yeah.
All right, cool. Sorry, my computer froze for a second. So I was like, oh no. Okay. How loading. All right, so to summarize again, we have 4 files: index.html, main CSS, forge3.js, forgeviewer.js. So all set. Now it's time to run our app. So now, next, we're gonna head over to running our app. So running locally and debugging. So using the sample, we will be opening a browser where we are gonna click on create a new bucket. We will give the bucket a name. So the name should be unique across all Forge accounts in the world. And then we're gonna right click on the newly created bucket and we're gonna choose to upload a file. This will trigger the OSS upload process. And in case you don't have any kind of file for testing, we have put up some links here that you can get. So I'm gonna show you how this works. So I'm gonna hit Revit, for example. Revit will send me to the knowledge page of Revit sample projects. So we can do simple, not too heavy one. So we click on it and we get back that Revit file. So now we can use this one to upload. And then we will expand that bucket 3 node with the file that we just uploaded. We're gonna select it. So you see now when select, we're gonna start the translation. This will trigger the model derivative job that we created in the model derivative.js file. And after a moment, you should be ready to click on that file again in order to visualize it in the viewer. So if we are ready, we head over to Node.js. And this is what I was mentioning before, that you can start debugging directly in the console in order to serve in a specific port. Okay, so let's give that a shot. So I believe we have all our files saved. Everything looks like it's supposed to. So now it's all up to the demo gods that actually do not mess up with my demo. So we're gonna head to debug console and we're gonna do start debugging. So now everything looks okay. So now it says that the server is listening on port 3000. So we head over here, we go to localhost 3000. Okay, so now we got started and now we have, let me just make this a little bit bigger, there we go. We have view models, Autodesk Forge application. There's nothing here because we actually haven't created anything yet, but we have a section for listing our buckets and objects. Little logo included for you. This is modifiable, so whatever, if you wanna use your own logo later, feel free to change that. So now we're gonna do a new bucket. And we're gonna call this AEC Hackathon. What day is today? 7/7/2020, Forge. I believe nobody has that name, so let's go ahead and create. All right, cool. So that worked. So now inside of the bucket, we don't have anything yet, right? So now we can do right click, we upload a file. We go to downloads, we select the basic sample project. As you can see, probably already downloaded like 3 times. So now we start uploading that file to the bucket. In just a second, the bucket will reload and give us the look that something already happened. We click on it. We see that this file is not translated yet. We start the translation, and now the translation has started. And while I wait for a moment, let me check on Q&A. And we have a question from James O'Neill. So give me 1 second, James. I will enable your mic right now. James. Where are you, James? All right. Hi, James. You can unmute.
He said, sorry, misclick.
Ah, okay, no worries.
There's another question related to Python in the Q&A panel.
Okay.
So is it
What
possible
is
to
the-
translate JS to Python if I wanted to use that language? Well, I'm
Yeah,
not
so
translate JS, you can just use Python instead on the server side.
yeah, correct. So I will say, like I mentioned at some point, the Forge services, most of them, for example, aside from the viewer, are REST API based. So you can use any kind of language in order to handle the part of the endpoints with that side. We do not have, unfortunately, a tutorial using Python in order to interact with the endpoints, but I believe that we are not using that many things in order for you to be able to do, I guess, the work on it. And I'm pretty sure that somewhere on the web you can find some sort of reference to people that have used Python in the past with the Forge platform. So I invite you to do a quick look over. We can also look for something for you, then send you whatever we find. I don't believe we have something that could, let's see. Oh, actually, Adam beat me to it. So there is something that he just sent you about the use of Python. Thank you, Adam. All right, so now if we gave it enough time, now we click on it. Now we get to see our newly loaded model directly on the viewer. And we have a way to start playing around with our model. I believe also, document browser is included, cool. So now we can have also, let's say if we want to switch and our file has 2D plans, we can do that. If not, coming back to the 3D one again, we can use the thumbnail functionality that this extension is actually given to us. And yeah, we can play around with that. We have, again, access to the model browser in order to visualize only the walls and the model, the plumbing fixtures, roofs, structural columns, site, all the doors, and so on. Okay, so now we have about 12 minutes left, but I want to give you some pointers to something else that if you got to this point, let's do actually a quick raise of hands. If you got to this point, can you raise a hand? I want to see. Awesome. Cool. Thank you, Saif. Awesome. Good job, Ramses. Vitaly, good job. Okay. I realized that maybe some of this content was a bit too fast. Unfortunately, we don't have enough time in order to kind of like do a full walkthrough, but the session is recorded. So once I have it available, I will send you a link to your email where you can get this video. And I believe we will probably be posting this somewhere with the AAC Hackathon people in order for you to be able to access it. At the same time, also feel free to reach out directly. You guys, all of you have my email, so feel free to reach out. And let me wrap up and get back to my, so let's stop the share. Interview. Okay, so we're past this point. So now, next trainings. Tomorrow, we will do a build BIM 360 integrations. So it is quite similar to this one. The only thing is that instead of getting the models from an object storage service like a bucket, if you have BIM 360 Docs account, we will be able to get that data from that location and be able to visualize the model that are also hosted in BIM 360 Docs. And one of the benefits of this BIM 360 integrations is you are able to extend functionality that might be more customizable for your business in order to create, I guess, your own, I would say, version of something that your customers will benefit using their BAME 360 data. Okay, so in regards to Forge and how do you get support, we use Stack Overflow. So if you head over to Stack Overflow, if you want to ask a question about specific support in regards to the Autodesk Forge platform, you can add any of these 3 tags. So if you do Autodesk-Forge, we have a system that extracts those questions from it, and we have an SLA of like 24 hours in order to help you out with your questions. At the same time, also with the Autodesk -viewer and Autodesk -model derivative, derivative can help you out with that as well. So, and there are many other questions that have been asked with that tag. So I invite you look over, maybe there is something already there where you can contribute to any of the other questions that some other customers may have in order to help them out with this. Okay. So with that, I want to take the last 10 minutes to see if you guys have any questions. And yeah, raise a hand. I can unmute your mic. We can chat. I'm here for you. You guys are a little bit shy today, or you haven't had enough coffee this morning, or your afternoon, it's getting to an end in Europe. So I don't blame you. But yeah, with that, well, thank you very much again, guys, for attending. I hope you found this useful. Please feel free to reach out in case you have any questions. Like I said, we're going to have some people available for you during the hackathon to help you out with any other question that you may have. If you want to use the Forge platform. So I see some questions coming in. Oh, you're welcome, James. You're welcome, you know. Thank you, Vitaly. And once I have the recording, I will be sending, I guess, a bulk email with the link for you guys to be able to access it. I will also talk to the AEC Hackathon organizers to see if we can publish that link for people to be able to access it later on. Or I can even like host it somewhere like YouTube or something like that. Okay, well, thank you guys again for your time, and I will catch you up next time. Take care. Stay safe.